Okay, this is lesson 1, part 2, and so we're going to be talking about a little bit more about cubic and quartic functions and a little bit about end behavior. So first of all, let's talk about a cubic function, and this is one of our new ones, and this is when you have the x cubed, so the parent function is just that. And notice that a couple of things, that when you're looking at a cubic function, that one end is going down and one end is going up. Also notice that the exponent is a 3, which is an odd number, so we call this an odd function. And it has to do with just that this number is odd. Now I call this a cubic function sort of a snake in the grass, because if you look at how much it resembles it, the snake is going through the grass and it's curling, going through, bending, and proceeding on, and that's pretty much what happens with the cubic function. For the parent function, it goes through the origin and then continues. It kind of looks like it's going straight up, but it's really not. It's really going a little bit out in both directions. So when we're talking about transformations from the parent function, of course this is the parent function, so there are no transformations. The domain for this one, the domain we're looking at x, and the range we're looking for y. So the domain can be any number, so negative infinity to positive infinity, and y could be any number, so negative infinity to positive infinity. If we talk about end behavior for this function, you'll notice that as x approaches negative infinity, so as we look along going negative, the function itself is dropping to negative infinity. So f of x is approaching negative infinity. As x approaches positive infinity, so as you're moving along this way, it is rising. So the function here is falling to negative infinity and it's rising to positive infinity. And that's what you're going to find with odd functions. Odd functions are going to go in two different directions. Sort of like the tail and the head are in two different directions on that little snake. When we look at quartic functions, you can see, like with this guy's arms, both of them are up, okay? Just like a quartic, both of them are headed up. It looks a whole lot like an x squared. The only difference is that the x to the fourth rises a lot faster. So if you put it in your calculator, you would see that the x squared one is a little bit wider. There's a portion, it's like that, and you'll notice that the x to the fourth is flatter down here at the bottom. So it is a little bit wider usually. Sometimes the quartic function will actually have a little hump in it, so like that'll be kind of W-shaped. Okay, so again, the parent function for this, f of x equals x to the fourth. There are no transformations. And when we talk about domain, we're talking about x, and we're looking at this one. So the x values can be any number because it is headed out. It looks like it's going straight up, but again, it's not. It is flared out just a little bit. So any number, so negative infinity to positive infinity, and the range is negative infinity to positive infinity. For our end behavior, as x approaches negative infinity, so as you're moving this way on the number line, the values are increasing to positive infinity also, And as x approaches positive infinity, the function itself also approaches positive infinity. And I do encourage you to use your calculator for graphing points. Remember that you can put in y equals, you can use it to put in a function, and then its second graph, and it gives you your table. So it gives you your values to plot, because you will be expected to plot points, specific points, not just little sketches.